Hey everybody, so in this video I'm going to talk to you about how to answer the questions on this summative review that is tomorrow. You get to use this paper if you have watched this video and taken the notes from Edpuzzle before 7:45 a.m. So one thing I want you to know is that I'm not going to write out all the answers. I am going to make notes and I am going to speak about it because if I wrote all the things down, the video would get really long. So pick an atom from group 1. These are called the alkali metals. And so the alkali metals, as you can see here, are in this group number 1, right there. Now, hydrogen is not an alkali metal. So we're going to pick Li. Li has 3 valence electrons, and it has 3 electrons right there. And so there are 2 on the first energy level and 1 on the next energy level. So it has 3 electrons total and 1 valence electron, right? The one right here on the outer shell is the valence electron. Now it says pick an atom from group 7. So group 7, 7A that is right here, these are called the halogens. And as you can see here, fluorine has 9 electrons. So 2 in the first energy level and 7 in the next energy level. So there are 9 electrons total and 7 valence electrons. So the key here is that you have to know when atoms are gaining and losing electrons. So let's answer number 3. Which of these atoms is most likely to lose its valence electrons? So the key here is that all atoms are trying to get to a complete shell of electrons. So we talked about this when we did these Bohr models. You can see that helium, neon, and argon all have complete shells. 2 in the first energy level, 8 in the second energy level, and there's 8 here for argon in the third energy level. But they're all full. So how does lithium do that? Well, lithium could either gain 7 to get to 8, or it can lose 1 to get to 2, which is like helium's electron configuration. So that's one reason is referring to the shells, right? Is atoms getting to complete energy levels, right? Lithium loses 1 to get to a complete energy level. Another one is ionization energy and Coulomb's law. So those electrons on the outside of the atom, the valence electrons for lithium right here, are far away from the nucleus. And so its attractions are going to be less for each other than these core electrons, these 2 on the first ring. So that's referring to Coulomb's law, that opposite charges attract, but when you increase the distance, you are going to reduce that attraction. Because lithium's valence electron has a low attraction for its nucleus, it only requires a little bit of energy to remove it. That's what ionization energy is. It's the energy to remove the electron, that first electron, that's the most loosely bound electron. So that's true for all the group 1 atoms. Lithium, sodium, potassium, rubidium, cesium, they all have a loosely bound electron which is far away from the nucleus. It only requires a little bit of energy to be removed. So that's the discussion about ionization energy, right? The ionization energy is low. For number 4, you have to know why atoms gain electrons. So firstly is a discussion of the shells. F has 7 valence electrons. When it's trying to get to 8, right, 8 is a very special number in chemistry because 8 means that the shells are full for almost all the atoms. So except helium, which is only 2. So F only has to gain 1 electron to become a full valence shell. And so when it does that, it becomes like neon's electron configuration. Now, the addition of electrons, right, is referring to electron affinity. Affinity means the attraction for something. So atoms are attracted to having electrons. When you add electrons to atoms, it releases energy. That's what these negative values are. Negative values mean that when you add electrons, the energy gets released. That's favorable for atoms. If it's positive, like down here, like for neon and argon and krypton, which are noble gases, you have to add energy to get them to do that, right? Think about Thanksgiving when you're full and you still, and then someone's asking you to try something else that you haven't tried yet that they made. You have to add energy in order to put that extra food in your mouth. Well, neon, argon, krypton, xenon, right? There are these noble gases over here on the right side. Their energy levels are full. You have to put energy in to add electrons to those atoms. So if we look at fluorine's electron affinity, you can see the electron affinity is very negative. You wouldn't want to say very high. It's very negative, right? And so that means that a lot of energy is being released when you add electrons to fluorine. And this goes along with the Coulomb's law explanation, because electrons are negative and the nucleus in fluorine is positive. So the electrons are going to be attracted to the nucleus of the fluorine because the nucleus has a positive charge. So that's the Coulomb's law part of that answer. Number 5. Why are those two atoms so reactive on their own? So part of the reactivity on their own is that lithium has this shell which is not full, right? It has 1 valence electron. Same with fluorine. It doesn't have a full energy level. It needs 1 more electron to become stable. So these atoms are not stable because their shells are not full. Their valence shells are not full. Now, when they undergo that transfer, right, when they're together, right, let's go up here to the top, right? If lithium is going to lose an electron and fluorine needs 1, it's going to get it from lithium when they're together, right? And now lithium is going to have 2 electrons in its outer shell. That's stable. And then now fluorine is going to have 8 electrons on its outer shell. Now that's stable too. And you notice that when lithium has 2 electrons total, it has 3 protons always. It's now going to be a positive 1 charge, which is a cation, right? Positively charged atoms are called cations. Now, when fluorine has 10 electrons, it always has 9 protons. It's going to have a negative charge, and those are called anions. Now you have a negatively charged atom and a positively charged atom, and now those together are attracted to each other to make a salt. So the cation and the anion that are formed are attracted to each other, right? It's a part of a Coulomb's law explanation. And they are now stable because both lithium and fluorine have full valence shells. On number 6, it says pick an atom above or below the alkali metal that you chose. So we chose Li. Let's choose Na next, right? So we have Li and Na below it. Now we know that as we go down the periodic table, it's more reactive. Remember, why is it more reactive? Well, as you can see here on the atomic radius paper, the atoms are actually getting bigger, right? The radius is getting bigger, the atoms are getting bigger. When the atoms are bigger, the valence electrons are now further away, right? They're further from the nucleus. And that is part of a Coulomb's law explanation, right? When you have further distance, between the electrons, like over here, the forces of attractions are going to be lower. And if the attractions are lower, the ionization energy is going to be lower. And you can see that right here. You can see with Li to Na there's a little drop, and then K drops even more, and then Rb drops even more, and Cs drops even more. The energy required to remove the loosely held electron is going to decrease. You can pull off that electron more easily from the atom. Number 7, you have 3 samples, xenon, calcium, and nitrogen. Which one of these is the least likely to react? So remember, you know that xenon is a noble gas. It's right here. Its electron shells, its valence shell, is full. Calcium, so it has 8 valence electrons, right? It's full in its valence shell. Calcium is over here. It has 2 valence electrons. It's in group 2. So it has 2 valence electrons. That valence shell is definitely not full. And nitrogen has 5 valence electrons, right? It's in the 5th group. So its valence shell is not full. So this one is the one that's the least likely to react because its valence shell is full, just like in these images over here for like neon and for argon. They have 8 electrons in their outer shell. So please look at the rubric that I have posted along with the link to this video and answer the questions here. What do you know now? What do you know how to do now? And what do you not know how to do? I'm hoping that you'll be reflective and try to figure out what questions that you'll be able to answer all these questions now. If you do have any concerns or questions, please message me and I will be able to respond to you. Thanks, everybody. Bye.